Chapter 1, the Field of Human Development, Developmental Research Methods. So in this section of Chapter 1, we're going to talk about the foundation for research, how theories are tested, the developmental considerations in research, and the widely used statistical approaches that are used in human development research. So let's start with the foundations for research. Well, first off, you probably have learned about this before, which is the scientific method. All research starts with some form of scientific method, where we're making observations about some phenomenon to test a theory so that we can see if we can understand a certain situation. So theory is a collection of ideas used to explain observations. So we have a hunch that this is going to happen based off of what we've observed. So we want to develop a theory based off of testing a hypothesis, which is an educated guess, a prediction where we narrowed it down to see what part of the hypothesis we could test, and to operationalize a definition so that we can explain our hypothesis and to define the variables in which one is trying to test. So then we have to select a method for testing. So what are we going to do? Are we going to do a scientific in the lab experiment? Are we going to do an observation? Are we going to interview people? How are we going to figure out what to answer our main question? So we review the results of the study, and then we revise the theory, share the results, and start the cycle all over again to understand. Because the scientific method is really to understand what will happen, or why does this happen, or how does it happen. And we have to construct these things to understand, but we have to ask a question, do research, come up with a hypothesis, an educated guess, so that we can test it to see if we can develop a theory or an understanding. So the importance of theory. Well, observations give us the what, theories give us the why. So observations create or modify the theory. The theory is used to form a hypothesis. The hypothesis is used to design the study. And then the research is performed. And then it may have to start over with the observation process again to see if we can find more information about that phenomenon that we're trying to study and understand. So we're going to stop right here for just a second for a pause and process. So answer the following questions and refer back to the slides as needed. So how are theories tested? They're tested in many, many different ways. Well, first off, the method that a researcher uses is dependent on the question that they create. So they may have to do a descriptive research because they're interested in understanding a situation. They want to describe a situation, what is going on. So an example of this would be, what is the opinion of the group? So what's the opinion? They would describe what the opinion is. Relational methods, this is where you're trying to understand the relationship between variables. So how is their opinion used to other characteristics? So understanding why they have that opinion would be a little bit more of a relational, or what caused them to have that opinion would be more relational. Causal, this seeks to show a cause and effect. So what factors affected their opinion? So what is impacting? And a lot of times relational and causal or causal can really impact both of those together at the same time. So descriptive research, this is used for describing purposes. So it seeks to describe human development. It determines and describes the way things are. So this is what you see, and it compares it to issues and topics that are like it or may even be different, but to understand why things are the way they are. The importance of this is that it's frequently used and it's used to influence opinions. So people will come in and they'll talk about why things are the way they are to make a difference. And some methods that are used are things like naturalistic observation, which is where you observe people in a normal environment to understand why things are the way they are. Ethnographic research, which is writing about people. So you're writing and you're understanding about people's relationships, but you have to understand and observe them to be able to write about them. So this may be something known as field study, where they go in and they're intermingling with somebody in their environment so that they can write about people. And then laboratory observation is also part of this as well, to determine why things are the way they are. And laboratory is used because you can control things in an environment. So it's really focused on the environment to determine and describe why these things are happening. Correlational research. This seeks to study if a relationship exists because between one or more variables. So some things that it does, it wants to understand why these two things have a relationship with each other. So an example of this would be people saying things like, the sun causes people to buy ice cream. The sun causes sunburn. Well, ice cream and sunburn typically happen during warm weather, but did the sun cause it? Or did it cause it because people were in the sun? Or did it cause it because it was summer months and ice cream to cool down? So the causation and the correlations have to be a little bit different. We have to be very, very careful because correlations don't equate causation. It may be a factor, but it may not be the exact reason why something happened. So some methods that are in correlation research are surveys, psychological measurements, interviews, observations, and archival data. So there's also types of relationships that we have to talk about with correlation research. And these are known as linear and curvilinear relationships. So linear relationships, this is where where plots of scores of two variables are described by a straight line. So linear would be this or this. Now, depending on which way the line is going, it could also be positive. So this shows that as one variable increases another, so it's saying there's a positive relationship between these two things. So these two things do interact with each other. They may not cause each other to happen, but they do have a strong correlation with each other that they happen at the same time. A negative correlation would be when the plots are going down. So when one decreases, the other decreases. So that shows that there's not a strong relationship between this and this. And that could be with the sun and the ice cream, or it could be gender and testing scores, and it could show a lot of different things. But this would be known as a linear relationship. And if it's going in an upward motion on a straight line, that would be known as a positive correlation. Or a negative correlation would be when the plots are going down and a line can be drawn to show. And then there's also no correlation. And no correlation is when there's no connection between the two. The plots are just random and all over the place, and it just shows that there's not a connection between the two variables. Doesn't mean that none of these mean that the variables cause each other, but there's a connection between them that needs to be looked at a lot more. And then curvilinear would be when it goes up and then it goes down. And this is when it could be described by things like functions. So age and athletic ability. Well, as someone gets older, so going from infancy, it may be down because they don't have the motor skills to be able to do it. But when you hit about 18, when you're in adulthood, that's when you're at your peak. So that would show a peak in age and ability. And then it goes down as we get older because our physical abilities change. So that would be an example of a curvilinear. And then there's also something known as a zero correlation as well. And that's kind of a no correlation, zero correlation, no correlation. So correlation coefficients do indicate how strong two variables are related. So a positive correlation, a no correlation, and a negative correlation. Negative would be when there is a negative correlation coefficient. And zero would be no correlation. And then positive, and there's different degrees of positive and negative. And as you can tell by this chart right here, zero would be weak. And the closer it gets to a 1, the stronger it is. And the more it gets to a negative 1, the stronger the negative correlation is. So there's either a weak, strong, but it's on that variable scale of how strong is the positive, or how weak is it, or how strong is the negative, or how weak that is. But the most important thing to remember when you talk about correlation is correlation does not imply causation. That anytime somebody says there's a strong correlation between two variables, that means then that they have to go explore that more. They can't say that it causes that because that may not be the case. That would be a false claim. And research wants to have more definite claims. So that's why they go back through the research cycle all over again when they find these correlations. So experimental research is also a design that researchers will do. And experimental research seeks to establish cause and effect relationships. And some things that you need to know about experimental research is things like an independent variable, which is a variable that is controlled or manipulated. So there's something that is changed throughout the experiment. A dependent variable would be a variable that is measured, and it doesn't change. It's stable. A sample, which is a subset of a population. So they choose a sample population that they want to examine. A random assignment would be when they pick their population and then they group them according to chance. So they may have a whole list of people that can be in an experiment. So they got their sample population, but then they go, okay, I'm going to randomly assign them. So they may pull a number out of a hat, or they may do some type of equation to get a number, and then they'll go, okay, so every third person's going to go in this group, every fourth person's going to go in this group, and they'll divide them up however they need to. Now, also, we have to know about something known as an experimental group and a control group. And a lot of times these are used as variables. So a control group would be known as your dependent variable, and your experimental group would be known as your independent variable. And an experimental group is a group that may receive some type of treatment, whereas the control group would receive a placebo, which means they were given nothing, so that they could compare the cause and effect relationship between the treatment that they were given. We also have to know about something known as experimenter bias, which is an influence of the experimenter, their expectations, or the behaviors. Sometimes they have a really strong idea that this is going to happen, and they may be biased at looking at other things. That's why we have to be careful with saying correlation does not cause causation, because they may really feel based off of their evidence that it does cause it, but they have to have really good evidence to be able to say that this causes this to happen. So some things that can happen to help with that are things like having a blind study, having them in random assignments, and things like that. So blind studies or double blind studies are when the participants do not know the group or the treatment that they receive. That also helps with um, experimenters having somebody else work with the groups and then they look at the data so that they don't know who was in the groups so that that doesn't sway them. And then also making sure that they have some other things we need to know is about having things like informed consent, which is where we provide participants who are in research that they're going to be studied. And they can either agree or they can disagree to be studied. And then also, a lot of studies, especially when we deal with people, have to go through something called IRB approval, which is an institutional review board that evaluates if a study is ethical and whether it's allowed to be conducted or if it has to change. So, IRB committees really focus on, is this experiment or research going to hurt anybody? Because in the past, and as we start talking about theories and research coming up in the next presentation, some of the studies were very unethical, but back not that long ago, they were considered. So things like giving children phobias or teaching children to be violent. Those were some things that were studied. And based off of that, we learned some really good information. However, it had detrimental effects on their development and how they interacted in their world. So, based off of those studies, policies have been put in place. So, it's very important that when anytime we're doing something with people, especially a vulnerable population like a child, an inmate, a pregnant person, somebody with disabilities, that we're not causing them harm and that they're able to advocate for themselves and understand that they do not have to be part of that study or that they can step back and not participate. So here's a time where we are going to pause and process what we have just talked about. So go back and review if needed the previous slides to help you answer these questions. So also in research, we have to talk about the developmental considerations of studying and researching human development type issues. Well, first, we have to consider what type of research we want to conduct. So considerations is an attempt to capture the significance of developmental change over a lifetime. So when we want to look at things over a lifetime span, we want to choose the best research design that's going to help us get the answers that we need. So there's three main types of research that focus on spans of time. And these are known as cross-sectional, longitudinal, and sequential. So longitudinal, there are some good advantages of a longitudinal study because this examines changes of individuals over time. It may be a year, it may be a lifespan, it may be um, from elementary school to middle school, from middle school to high school. And what it does is it provides a developmental analysis of how they've changed and influenced over time. So an example of a longitudinal study that pretty much all of us have been a part of at one time is Integrate Test. They have collected data on us from all these different years and they've used it to compare our cognitive growth from third grade all the way up until high school. And they're really looking to understand our changes and if we're improving or so that they can make changes in educational practices and things like that. Now, there are some disadvantages to this type of research design. It can be very expensive. Collecting data and following people over a span of time can be very expensive. It can also take a very long time. Participants can also drop out. So that could be an example too with state testing. They may have data on someone and that may have dropped out of high school, and then they lost a participant to understand what happened. So they know that they dropped out, which causes a flag for them to research what happened and going back and looking at the data to see what may have caused that to happen, but they didn't have the opportunity to improve that person's situation. It can also have the possibility of practice effects, and it may not examine cohort effects as well. So it may give them the what do we know, but not how did we get to knowing that. So state tests uh, don't really measure how teachers taught us. It just, did they know the material? So it can have some disadvantages, but it really depends on what type of longitudinal study it is and how they go about collecting the data. Now, a cross-sectional research design, this examines change between participants at different ages at the same point in time. So it doesn't go from third grade, fourth grade, fifth grade, sixth grade, all the way up. Now, an example of this would be the state writing test, where you had one in third grade, then you had one in seventh grade, and then you had one later. That would be seeing how writing has improved at different chunks of time. And it provides information on age-related change. So were they able to formulate sentences better? Were they able to accurately portray the prompt and answer it fully? But it looks at different things. It doesn't examine change over time, though, or cohort effects. So again, it doesn't really look at how they got there. It just looks at, did they get there? So what changes can we see between point A and point B, not the in between of point A and point B. Now, sequential research design, this examines changes within an individual over time. It examines changes between participants at different ages at the same time. So it's kind of combining longitudinal and cross-sectional together. Now, this one can be used to examine cohort effects. And it may be very expensive, just like longitudinal, because it's a combination of the two. And it could have the possibility of practice effects, but again, it all depends on what they're looking for and what they're using as their measures. If they're only using a multiple choice test as a measure, they're not really seeing how things were taught, or how writing really improved, or how many writing prompts did they have to practice to get to that point? How many essays did they write? It doesn't look at that. It just looks at, this is the point and this is the point. It doesn't have the in-between necessarily in there. So now we're going to do another pause and process where you reflect upon what we just talked about and what you have read so far in your textbook. So now we're going to talk about some widely used statistical approaches to studying human development. So the first one we're going to talk about is something known as multiple regression. And this is a method that allows a researcher to predict one variable based on the values of other variables. And this is where the researcher comes up with something known as a null hypothesis. And they're studying to see if their null hypothesis is true or if their null hypothesis is not true. So an example of this would be, there is no relationship between education and of respondents and the number of children in families. So the null hypothesis may have been, there is a relationship between education and the number of children. But after studying that, they may have to go back and say there is none. So there is none, and they're trying to prove it, see if it's proven true, so that they can say the null hypothesis is true or the null hypothesis is not true. And another example would be there's no relationship between family and income and the number of children in families to see if they can prove that null hypothesis true or false. But it's all based off of a prediction. And then they have to use research methods and gather data to see if they can prove that true or false. Another type is a time series analysis. And this is a study of the same variable across time. And this would be this could be weekly or yearly. It could be state testing among years just to see what patterns and trends are occurring. So they may study third graders in 2000, and then they'll study third graders in 2001 to see if they can see what's going on and compare it. They can do it with many, many different things to see what is the difference, what's going on. Another type is meta-analysis, and this is data from numerous studies on a specific topic where they're analyzed and synthesized together. So it's combining the results of several studies together. So an example of this would be, can 8-year-old infants extract isolated word forms from natural speak? Well, they're going to look at information from study 1 and study 2 to pull it together to see. So one may say yes, and then one may say no, and now they're going to look at it, and then they can expand on it later, combining their research methods to see what they may need to change to get better data, or maybe they need to use a different statistical method to see which one is correct or incorrect, to see if there needs to be changes in the research process. Now, another type is structural equation modeling, which is known as SEM. And this model is developed to explain patterns of relationships among variables. So they're very much looking and testing whether one model is better than the other in regards to the degrees of freedom. So the null would be the models are the same, and then the alternative hypothesis would be the models are different. And they would run a test to see which one is the better model for their structural equation research that they're doing. So we're going to stop again for a pause and process. Again, make sure that you go back and refer to the slides and to your textbook as needed to address these 3 questions. And that is the end of Chapter 1, Part 2.